Hello everyone. Today in this PPT we will be continuing the chapter transducers and sensors. Okay, that is the unit 2 in mechatronics. It is for electrical and electronics students of 6th sem. Okay, then the contents what we will be covering: Hall effect transducers, then photoelectric transducers, then photoelectric tachometer, then strain gauge, then wirewood strain gauge, then foil strain gauges, then semiconductor strain gauges, capacitive strain gauges, western bridge, then next one sensors, proximity sensors, light sensors, and temperature sensors. These all we will be seeing in this chapter, in this unit. Okay, then first one, Hall effect transducer. So Hall effect transducer is what? It is the transducer in which Hall effect is utilized to measure various electrical and non-electrical quantities. Okay, the what are the applications of it? It is used in displacement measurement. Okay, the next one, how it is done? You can see over there the diagram of an Hall effect transducer. There will be what? This Hall effect transducer, the Hall effect element will be located in the gap of the magnet, permanent magnet. Two permanent magnets are there. In between that gap, the Hall effect element will be there. Okay, the next, the ferromagnet plate is there. That ferromagnet plate, when it changes its position, okay, when it changes its position, that time the voltage output of the Hall effect element will be changing. Okay, so the field strength produced in the gap due to the permanent members is changed by changing the position. So the field gap, that is permanent member, field strength will be changed when the ferromagnet plate will be moved. Okay, due to that what will happen? The voltage output also it will be changing. Okay, like this, in this manner your Hall effect transducer will be working. Then next one we will be seeing about the photoelectric transducer. So what is this photoelectric transducers? So these photoelectric transducers, they operate on the principle of what? Light. Okay, so the photoelectric transducer operate on the principle, that is when the light strikes on the special combination of materials, then what it can change? Electrons may flow, either electrons may flow, then voltage can be generated, then the resistance change may take place. Okay, then what are its applications? So these transducers find the following applications. What are the applications? That is control engineering, precision measuring devices, then exposure meters used in photography, then in solar batteries as source of electric power for rockets, television, counting machines, etc. The next one we will be seeing about the phototachometer. So what is this phototachometer? So this phototachometer transducer operate on the principle of what? Light strikes on a special combination of material, then what will happen? Either the electrons will change, then a voltage may be generated, or the resistance may change. Okay, so where it is used? It is used for control engineering, then precision measuring devices, and exposure meters in photography. Then photoelectric tachometer, you can see over there the diagram, there will be what? It consists of an opaque disc. Okay, so there will be one disc. In that disc there will be holes. Okay, so this disc will be mounted on the shaft. Okay, the disc has number of equivalent holes, as I told you. So on one side of the disc there is a source of light. So you can see in the diagram there is one light at one end. Okay, and at one end there will be what? There will be a light source, and at one end there will be a sensor, that is your light sensor. Okay, so when you rotate the disc, holes and opaque portion of the disc come alternatively between the light source. When the light source, they fall on the light sensor, that is when a hole comes in between the two light, light passes through the holes and it will fall on the light sensor. Okay, when the result, with the result what it will be? The output pulse is generated. But when the opaque portion of the disc comes in between, what will happen? The light from the source is blocked. Okay, so when there will be an opaque portion, that time what will happen? The light source will be blocked. Hence what will happen? The light source will not reach the light sensor and there will be no pulse. So thus whenever the light will go through the hole, when hole comes, the light sensor will sense the light and it will give one pulse. When the opaque portion will come, that time the light source will be blocked by the disc and the light sensor will not produce any pulse. So these pulses are counted and measured through an electric counter. Okay, the number of pulses generated depends upon the following: the number of holes in the disc and the shaft speed it will be. Okay, so this will be, in this manner your photo tachometer will be working. The next one is what? Strain gauge. Okay, so in this strain gauge, what will happen, the when this metal conductor, either it is stretched or compressed, its resistance will change. Okay, on account of the fact that both the, what will happen, the length and diameter will be changing, so the resistivity of the conductor also changes. So its strained, its property is also called as what? Piezo resistance. Okay, the strain gauge is a measurement transducer for measuring strain and associated stress. So types of strain gauges are what? Wire wound strain gauges, foil type strain gauges, semiconductor strain gauges, and capacitive strain gauges. Okay, the next one, wire wound strain gauge, we will be seeing. So you can see over there in the diagram, the first we will be seeing. So in wire wound strain gauges there are two types, that is, first one, bounded strain gauge and unbounded strain gauge. So first one we will be seeing, that is bounded strain gauge. So it is composed of fine wire wound and cemented on a resilient insulating support, usually a wafer unit. Okay, such units may be mounted upon an incorporated mechanical elements. So while there are no limits to the basic values which may be selected. So example may be taken for the order of 100 to 500 ohms. So you can see over there the figure of the resistance wire strain gauge. Okay, so how they are done. The first one you can see, that is a linear strain gauge. Second one is what? Your resettler. Then next one it is base, that is your torque gauge it is. Then last one is what? Your helical gauge. Okay, the next one is unbounded strain gauge. So unbounded strain gauge, what it will be, here you can see in the diagram, the M and N are attached by rods. Okay, the M and N are respectively 2 points between which displacement is to be measured. So they are between the points M and N, 2 are points that the displacement will be measured. So pickup and measuring networks are energized from similar by isolated source. Unbalancing originating in pickup is detected and balance of servo actuated measuring network providing a reading of strain or graduated scale. So between the M and N attached, when we that it will, the displacement takes place, means there is an movement, that time what will happen, means either stretching or compressing, that time you will get the what, the reading of the strain or an graduated scale. On graduated scale you will get the scale, you can see in the diagram that the pointer will be moving. Okay, on that scale accordingly you will get it. So you can see over there. So these wires will be compressing of 4 arms of the Wheatstone bridge network, of which 2 opposite arms are tightened and the other 2 slacked by the displacement. So 2 arms will be tightened and 2 will be what? It will be depending upon the movement. Okay, they can move. So when a bonded gauge tends to respond to the average strain in the surface to which it is cemented, the unbounded form measures displacement between the 2 points to which the respective supports are attached. Okay, so like this the strain gauge will be working. So unbounded strain gauge. So here you can see in the diagram there is a M and N, 2 points are there. So the 2 points, in between the 2 points whatever the displacement will be there, that it will be calculated. Okay, so you can see in the besides diagram there is a pointer, that pointer will show you the displacement. Okay, so whatever the measured quantity, that it will be showing over there. So here what it will be, in this there will be 2 points, they will be what, they will be tightened. Okay, and 2 points they will be what, they can move. Okay, so according to that the pointer will be moving and it will give you the readings. Okay, the next one is foil strain gauge. So in this gauge, what will happen? In this gauge, the strain is sensed with the help of metal foil. Foil gauge have a much greater dissipation capacity as compared with wire wound gauges on account of their greater surface area and the same volume. Due to this reason, they can be employed for higher operating temperature ranges. So for higher temperatures, this can be used. Okay. Then here you can see the typical foil gauge. The characteristics of foil type strain gauge are similar to those of the wire wound strain gauges. Okay, only what the same as that of wire wound strain gauge. The resistance value of the foil gauge which are commercially available is between 50 to 100 ohm. The advantage of foil type strain gauge is that they can be fabricated economically. Okay, the next one is what? Your semiconductor strain gauge. So in semiconductor strain gauges, it will be depend from their action upon piezo resistivity effect, that is change in the value of resistance due to the change of resistivity. That is what the if it changes either in area or length, that time. Okay, these gauges are used where a very gauge factor and small envelope are required. You can see the diagram of the semiconductor strain gauges. Okay, for semiconductor strain gauges, semiconductor material such as silicon or germanium will be used. Okay, the typical strain gauge consists of strain sensitivity crystal material and leads that are sandwiched in protective matrix. Okay, you can see in the diagram. Then next, the production of this employs conventional semiconductor technology. Okay, its thickness is will be of 0.05 mm and bonding them on a suitable insulating substance, that is such as Teflon, gold, lead are generally applied for making the contacts. Then next one, advantages. This gauge have high gauge factor, then excellent hysteresis characteristics. Then these gauges can be very small ranging in the length of 0.7 to 7 mm. Okay, disadvantages. The major and serious disadvantage is that these gauges are very sensitive to change in temperature. Linearity of these gauges is poor. Okay, the next one is what? Capacitive strain gauge. So in this capacitive strain gauge, it uses the principle of variation of capacitance. Okay, so you can see over there two electrodes are there, and there is an insulating film is there. Okay, two electrodes, above that there will be an insulating film. Okay, so here the electrodes are flexible metal strips. So the electrodes, they are what? They are flexible metal strips about 0.1 mm thickness. The strain to be measured is applied on to the top plate. So the top plate will be there, no? There the strain will be applied. Means you can apply some force. This changes, what it will change? The distance between the curved electrodes. So when the distance between the curved electrodes change, what will happen? There will be change in the capacitance. Okay, so this strain capacitance relationship is generally is not linear, but variation in dimension, shape allow gauge characteristics. Okay, so a capacitance strain gauge has capacitance of about 0.5 picofarad. Its overall size is what? 5 mm into 17 mm into 1 mm. It uses a polyimide film of insulating material. So the temperature it can be used, means the temperature it can withstand is 300 degrees Celsius. Okay, the next one is Wheatstone bridge circuit. So this Wheatstone bridge circuit technique can be used in the following ways. One is null mode and another one is deflection mode. So here the diagram we can see over there, we will be seeing the null mode. Okay, the resistance with no strain are so arranged that the VB will be equal to what? VC. Okay, then here the galvanometer gives zero decay. When VB equal to VC, what will happen? The galvanometer will be showing zero deflection. Okay, then what it is? R1 divided by R3 is equal to R2 divided by R4. Okay, so you can see over there. So here when R1 is equal to Rg and equal to unstrained resistance of the gauge, in the measurement of strain, generally R1 is the strain gauge. Okay, So your R1, there we are in diagram it is written, see the gauge. Okay, R2, R4 are the fixed resistance. Your R2 and R4, they will be fixed resistance, that is down one. Then R3 is what? That is variable resistance, that marking is done. Okay, when the gauge is changed, it resistance R1 changes by an amount of dR1. The change unbalances the bridge. So due to the strain, what will happen? The bridge will be unbalanced, resulting into the what? Deflection of the galvanometer. The balance is then regained by adjusting the R3 by an amount dR3. Okay, so what will happen? Whenever the gauge is changed, that time what will happen? The R1 changes the amount, that is to a dR1. Then this results to the unbalance. Due to that, what will happen? The galvanometer will show the deflection. Okay, when you want to balance it, we can balance it by using the variable resistor, that is R3. Okay, like this the Wheatstone bridge will be working. Then next one is sensors. So sensor is what? It is a device that it will detect and respond to some type of input from the physical environment. Okay, so here the specific input could be what? It can be the sensor. The specific input to the sensor can be light, heat, motion, moisture, pressure, or any one of the greater number of other environment phenomena. The output is generally a signal that is converted to human recordable display at the sensor location. Okay, so here some examples of the sensors are: it is used in a mercury based glass thermometer. The input is temperature here. Then next, the liquid content expands and contracts in this response. Okay, then next, an oxygen sensor in a car's emission control system detects the gasoline oxygen ratio. Okay, then one more, motion sensor in various systems including home security, lights, automatic doors, bathroom fixtures typically send out some type of energy such as microwave, ultrasonic waves. Okay, or light beams and detect when the flow of energy is interrupted. Then one more, a photosensor that detects the pressure of visible light, infrared transmission, and ultraviolet UV energy. Then how we have to select the sensors. So here the variable to be measured, its nominal value, the range of the value. Then next, the selection of sensor, the nature of measurement required, then the nature of output and required. Okay, then next, the possible sensors can be identified by taking what? Determined by the signal conditioning requirements in order to give suitable output signals at the measurement. Then next, what? According to what? Their range, accuracy, linearity, speed of response, reliability, maintainability, how much life you want, power supply requirements, then ruggedness and cost and availability. Okay, the next one we'll be seeing is proximity sensor. So in this proximity sensor, what it is? It consists of an element that changes either its state or an analog signal when it is close to but often not actually touching an object. Okay, so here is the photo eddy current. First one we'll be seeing about the eddy current proximity sensor. Okay, so here the diagram is there, eddy current proximity sensor. So how it will be working? When a coil is supplied with an alternating current, an alternating magnet field is produced. Okay, so there is a coil, so that when the coil we will provide an alternating current, then alternating magnetic field will be produced. If there is a metal object, then one metal object will be there close to it, then in the close proximity to this attending magnetic field, then the eddy currents are induced in it. The eddy currents themselves produce a magnetic field which distorts the magnetic field responsible for their production. Okay, so you can see over there in the diagram what? One coil will be there and uh, one metal will be there. Okay, whenever the sensor coil will be that metal, whenever the reference coil that it will be given some current, the magnetic field will be produced. Okay, so due to that magnetic field, it will be attracting that thing, and what will happen? An eddy current will be induced in it. Okay, So advantages, it will be of small in size, relatively expensive, high flexibility and high sensitivity. The next one, capacitive capacitance proximity sensor. So it consists of a simple plate with the object acting as the other plate. As the object approaches the sensor, separation between the plate of the capacitor and object changes. Okay, so you can see over there, that is sensor plate is there and air will be there in between and one more object will be there. When they get attracted towards each other, what will happen? The object, when the approaches the sensor, the separation between the plates what will happen, it will be changing. Okay, plate of the capacitor and object changes, which becomes significant as object is closer to the sensor. Okay, so in this manner this will be working. The next one, inductive proximity switch. So an inductive proximity switch consists of a coil wound around a core. When the end of the coil is close to the metal object, its inductance changes. This change can be monitored by its effect on a resonant circuit, and the change used to trigger a switch, it can only be used for detection of metal objects. Okay, so like this inductive proximity will be there. So in this, what, a coil will be there. Okay, that will be wound on the core. So when the end of the coil is close to the object, it changes the inductance. Okay, means when it moves close to the that metal object. The next one, pneumatic sensors. Okay, you can see over the diagram, these sensors involve the use of compressed air, displacement or proximity of an object being transformed into the change in air pressure. So whenever there is change in an air pressure, that time what will happen, there will be, due to that change in the pneumatic sensor will be working. So low pressure air is allowed to escape through the port in front of the sensor. This escaping air in the absence of any close by the object. Okay, so here, if there is a close by object, the air cannot so rapidly escape and result in that pressure increases in the sensor output port. The output pressure from the sensor thus depends upon the proximity of the object, means the distance between the object. If it is close, then the air cannot escape. Pneumatic sensors, they are used for measurement of the displacement of fractions of millimeters. Okay, this can be a typical of 3 to 12 millimeter. The next one is what, light sensor. So light sensors, what all it will be there? The first one, it is photodiode. So photodiodes are what? Semiconductor junction diodes, which are connected into a circuit in reverse bias. They are connected in reverse bias. So they will be giving very high resistance. Okay, so when the light falls on the junction diode, resistance drops and the current in the circuit rises. So when the light will fall on that, what will happen? The resistance will be less, so the current will flow. When the light will not fall on that thing, this photodiode, the resistance will be high and the current will not flow. Okay, in this manner this photodiode will work. The next one is phototransistor. So phototransistor have a light sensitivity collector base. So the collector will be nothing but a light sensitivity will be. So the base will be nothing but PN junction. When there is no incident, there is a very small collector to emitter current. Means when the light is not there, there will be very small collector to emitter current. When the light will fall on that base, current is produced. That is collector base PN junction will, in that current will be produced. When there is no incident, there is very small electric current. Okay, when the light is incident, the base current is produced. So like this it will be working. The next one is photoresistor. So it has a resistance which depends on the intensity of the light. So this photoresistance, what it will be, depending on the intensity of the light, means how much light will fall, depending on that its resistance will be either it will be increasing or decreasing. That is, it decreasing linearly as the intensity of the increases. Means when the light will increase, the resistance will decrease. Okay, so here it, cadmium sulfide photoresistor is most responsive over here. Okay, so An array of light sensor is often required in a small space in order to determine variations of light intensity across the space. Okay. Then next one, what we will be seeing, that is optical type encoder. Okay. So in the contact type arrangement, there is direct contact between the brushes and encoder disc. But disadvantage what it will be there, wear and tear of the brushes will be. That's why what we will be doing now, optical type encoder means there will be no contact. Okay. So here it is a non-contact encoder, you can see over there in the diagram. Okay. Then the disc has transparent and opaque areas. So disc will be having what? Transparent and opaque areas corresponding to conducting and non-conducting. Means one time it will be transparent, one it will be not transparent. Depending on that, whenever the light transfers, then it will conduct. Whenever the light will not transfer, that is opaque will come in between, that time it will not conduct. Like that it will be working. The light source is used along its slits and photocell. Okay. So like that it will be working. So here the photocell corresponding to the particular track would produce an electrical output if the transparent portion is in front of the slit and light source, giving the on one, while no electrical output from a cell would correspond to off, that it will be 0. Then next one is temperature sensor. So temperature sensor, what it is? Here it is, it will be detecting temperature or heat. This type of temperature sensors vary from simple on-off thermostatic devices while a controlled domestic hot water heating system also. Okay. So here contact temperature sensor type. First one, types, there are two basic types, that is contact temperature sensor types and non-contact temperature sensor type. So first one we will be seeing, that is in contact temperature size, the temperature sensors are required to be physically in contact, whereas in non-contact temperature sensors use convection and radiation to monitor change in temperature. Okay. So first one, the bimetallic thermostat we will be seeing. Okay, the diagram is over here. So in this, the thermostat, it will be consisting of two thermally different metals stuck together back to back. When it is cold, the contacts are closed. Okay, so you can see over there, when upper one, first one, when it will be cold, that time the bimetallic strip and the electrical connection, they will be closed. Okay. Then next, when it gets hot, so this when heat will be applied to that bimetallic strip, okay, one metal it will expand more than the other and the bonded bimetallic strip bends. So you can see in that second diagram, that is bimetallic strip, it will get bent and it will open. So due to this opening of the contacts, what will happen, the current will not flow. Okay. So like this it will be working. Then next one is what, the thermistor. So thermistor is what, is another type of temperature sensor whose name in the combination it will tell you, that is thermal alloy sensitive resistor it is. A thermistor is special type of resistor which changes its physical resistance when we expose it to the temperature. So whenever it is exposed to the temperature, the resistance will be changing in this thermistor. Okay. The next one is what, resistive temperature detectors, RTDs. They are nothing but precision temperature sensor made from high purity conducting metals such as platinum, copper, nickel wound into a coil whose electrical resistance will be changing according to the fluctuation in the temperature. Okay. The next one is what, the thermocouple. So this thermocouple is by far the most commonly used of all type of temperature sensors. Thermocouples are popularly due to the simplicity, easy of use. Okay. So here thermocouples and thermoelectric sensors that are basically consisting of two junctions. They are of dissimilar metals such as copper and constantan welded on a crimp together. One junction it will be kept constant and the constant temperature called the reference cold junction, while the other measuring junction, that is hot junction, when the two junctions are at different temperatures, voltage will be developed across the junction. So when these two junctions, what they will be under different temperatures, what will happen? Voltage is developed across the junction, which is used to measure the temperature. So when the two junctions, one will be common and one more will be what? It will be hot, means it will be varying. When we vary the temperature, that time the voltage will vary, and will accordingly the temperature it will be showing. Okay, like that it will be working. Okay, by this we will be completing this chapter, second unit. Thank you.